Oh.
Okay, thank you. Hi everyone, good evening, good afternoon. Do you hear us? Please write in the chat if you hear us. Okay, good, perfect. So, welcome to today's webinar, and I'm very happy and excited to see the presentation of today, and happy that we have all of you here to discuss the topic of exploring generative AI from neural network to practical application with our speaker, Dr. Salim Al-Msih. So I appreciate your dedication, your engagement for the online chapter, and as well for the online webinar with us to the webinar that we organized to complete your understanding of the online chapter. And thank you for taking the time to participate, and we look forward to your continued engagement for next week and the exam to get your certificate. So let me introduce our speaker for today, Dr. Salim Al-Msih. She is a postdoctoral researcher at the Department of Computer Science at the University of Luxembourg. She has a PhD in computer science from Ibn Tufayl University, Kenitra, Morocco, in a computer program with Aix-Marseille University. Her research interests include natural language processing, machine learning, deep learning, and transfer learning. So we are honored to have her to share with us her work, knowledge, insights, and funding. So during the presentation, if you have any question or comment, we encourage you to use the chat to submit them. So please feel free to send your question during the talk. We will moderate the chat during the Q&A session. Our speaker will be approximately talking about 45 minutes, followed by 15 minutes or 20 minutes for the Q&A session. As I said, we will be moderating the question to our speaker after the talk. So, and please feel free to write the question we cannot answer during this presentation in a Reddit platform. So if you have any issue to connect to have access in Reddit, please write in the chat. We can help you to get access to Reddit platform, because I don't see too much question in the Reddit. So I'm asking myself if this a problem, if a technical problem or something else. So please be active by sending your question in the Reddit platform.
Sana, 1
yes.
second. Could you say a few words about the quiz?
The quiz.
Yes.
Yeah, I was expecting to talk about the quiz next week, because the next week is the last session, but it's okay, I can say something. So the quiz, so we have 6 speakers for 6 webinars. So for each webinar content, we will prepare 5 questions. The speaker will be sending 5 questions of their talk. With the multi-choice answer, so you don't need to complete or to write, but just to select the correct answer from the option we will give for each question. So in total, you will be having 30 questions for the 6 webinar, and the quiz need 2 hours to pass it. We will be opening the platform for the quiz during 1 week, starting from 17 June. And you have 3 chances to pass the quiz. So once you open the quiz, you started your first chance, or your second, or the third one. So to pass the quiz during 2 hours. So the quiz it doesn't really take 2 hours, but we calculated that 4 minutes for question to read it and to answer to it in a comfortable way. That's everything about the quiz. So if you have any question, feel free to write it in the chat. We will be recording the webinar as we did for the last webinar, for those who cannot join us, or for those who want to rewatch it again to prepare for the for the quiz. So I will give the floor to our speaker, Salima, and thank you. Thank you, Salima.
Thank you, Sana. Thank you, Sana, for the kind presentation, and welcome everyone. I am very happy. It's wonderful to be here with you and to attend this webinar or to participate. So today we will focus on another exciting field of artificial intelligence, which is generative AI. And our presentation will be an introduction to generative AI with a special focus on large language models. So generative AI is one of the most technologies of the information age, which continuously advancing and transforming various industries with its ability to create new content, to generate insights, and also to drive some innovation. So this lecture will take approximately 45 minutes, and you are welcome to ask any question in the Q&A section. So to begin, I will provide a high-level introduction to machine learning, which is essential for understanding the foundation of generative AI. Then I will define what is generative AI and its importance. Then I will briefly present natural language processing, highlighting its challenges and how large language model can address some of these issues. So I will discuss the architecture, the training process, the usage, the capabilities, and some limitation of large language models. So let's get started. So before we need to clarify the AI terminology. So as we have seen already, artificial intelligence or AI is a subfield of computer science that enables machine to mimic human behaviors. It's trying to create intelligent system that can perform tasks that typically require human intelligence, such as visual perception, speech recognition, decision making, and so on. So there are several key terminologies within the field of AI, including machine learning, deep learning, reinforcement learning, natural language processing, generative AI, and so on, like robotic, computer vision, and other fields. So today we will draw a Venn diagram to clarify this AI terminology. So artificial intelligence can be considered as the biggest subset that comprises several tools or several subsets like machine learning. For example, machine learning. So machine learning, it's subsets of artificial intelligence, which has been defined by Arthur Samuel as a subfield of AI that gives computers the ability to learn from data without being explicitly programmed. What do we mean by without being explicitly programmed? That means that the computer is not given a set of rules or instruction on how to solve a specific task or problem, but instead, the computer is presented with a large amount of data, and the machine learning algorithms enable the computer to learn from this data and develop its own understanding and rules based on the patterns and relationships between the data and the relationships that it discovers by himself or itself. So usually in machine learning algorithms construct some predictive models by learning from a large number of training exams. Because usually in traditional programming, the programmer writes code that specifies the exact steps the computer should take to solve a particular problem. However, by using machine learning, the computer can learn to recognize patterns and make decisions based on data without requiring explicit programming instructions for every possible scenario. So we have artificial intelligence. Inside artificial intelligence, we have machine learning. Inside machine learning, we have deep learning. So what is deep learning? Deep learning is a subfield of machine learning that uses artificial neural networks to learn complex patterns from data. So usually artificial neural networks try to mimic the behavior of the human brain by trying to replicate the functioning of biological neurons. So this figure illustrates the general architecture of an artificial neural networks. So in this diagram, you can see that there are three main layers: the input layer, the hidden layer, and the output layer. So the input layer receives the input signals, which are the features or data points that the model will process. So the input, like for example, if we want to classify an image, we need to transform this image into features, and this feature will be the input. Then we have the hidden layer. The hidden layer consists of neurons that perform the computation and extract patterns or features from the input data. So each neuron is connected to neurons in the subsequent layer, trying to mimic the way biological neurons communicate. And we have the output layer. So the output layer is responsible for producing the final results. It can be prediction or classification or text, it depends. So this is the general architecture of artificial neural network. So it's worth mentioning that we have only one input layer and one output layer, but we could have many hidden layers. So there are different types of deep learning models. There are feed-forward neural networks, which are mostly used for classification, for prediction. We have the convolutional neural networks, which have been developed mainly to solve computer vision tasks. We have recurrent neural networks, which have been used mostly for natural language or text processing. And we have the transformer, which has revolutionized the NLP or the generative AI field. And we have many other deep learning models like generative adversarial neural networks, diffusion, and so on. So machine learning, we can classify the models of machine learning according to the learning paradigm. So according to how this machine learning learn. So we have many types. We have the supervised machine learning, we have unsupervised, we have semi-supervised, we have reinforcement learning, and those days most researchers talk about self-supervised instead. So what is supervised machine learning? Supervised machine learning are algorithms that are trained on labeled data sets that we have, for example, here, the data, and we have their labels. And the model learns from the data and the labels to make prediction. For example, here, then we have the training data set is labeled. The model learns from this labeled data set, from the data and its labels. And during test, we give to the model new data without labels, and the model itself tries to predict the category, the class, or depends if you are predicting a class or a value or. So some types of supervised machine learning, we have the conventional machine learning or the traditional machine learning like support vector machine, decision tree, linear regression, and so on. And we have deep learning models, including the feed-forward, the recurrence, the convolution, and so on. So this is supervised machine learning. The model learns from labeled data sets. We have unsupervised machine learning. Unsupervised machine learning are trained using unlabeled data sets, and the model predicts the output without any supervision. Like for example, here we have only the data which is not labeled, that we don't have labels, and the model itself tries to predict or to classify or to cluster this data. So there are algorithms like clustering algorithms like Cummings, hierarchical clustering, and we have also unsupervised deep learning models like autoencoders, variational autoencoders, generative adversarial networks, and so on. So deep learning models can be supervised or can be unsupervised. So let's see, let's clarify more the difference between supervised and unsupervised. For example, supervised learning, we have the input data, X. So this data is given to the model. The model will predict the output. Like, for example, I want to predict the weather of today. So it will predict the output. Then we will compare the predicted output with the expected output, because this data is labeled. We have the observation and we have the label of this observation. So we will compare the predicted output with the expected output. Then we need to minimize the errors between the predicted output and the expected or the ground truth output. So we try to minimize the error between the two values. Then we update the model. And this is the learning, how supervised learning do training. But for unsupervised learning, we have only the input data. The model itself tries to classify this or to cluster this data, and then it generated examples or clusters. In addition to supervised and unsupervised, we have semi-supervised machine learning. The semi-supervised machine learning models try to learn from both the labeled data sets, like for example, here we have the input data, we have some partial labels, and we have other data sets which is not labeled, and the model try to learn from both data sets. And semi-supervised learning is useful when labeled data is scarce or it is expensive to obtain. So we have seen supervised, unsupervised, and semi-supervised machine learning. But we can also classify machine learning according to if it is discriminative or generative. So discriminative models or discriminative machine learning and the generative. Discriminative, it's used for classifying or predicting. And it is usually trained using labeled data. Mathematically speaking, the discriminative models try to learn a decision boundary between the two classes, and usually it's try to predict the conditional probability. For example, I want to predict the class of this document, the class of this given, for example, I want to predict if a sentiment is positive given the class of this sentiment, given its probability of the class given the document. So it's a conditional probability. For generative models, they try to generate new data and they focus on the distribution of the data. It's try to learn the characteristics of each class, and it is modeled using the joint probability. So here there is an example. For example, if we are using a discriminative technique or a discriminative machine learning algorithm, we have an input which is a dog. So the model will try to classify if this picture is dog or cat. So this is here, there is a classification or prediction. So we have data, we have labels. So the predictive machine learning model learns the relationship between the data and the label, and then predicts the output, the label. So this is the discriminative technique. For the generative machine learning, for example, we have a dog. The model tries to generate new content based on the input content. So for generative model, it will generate a new image for dog. It will not classify, but it will generate a new image based on the input data. So we have unstructured content. When we say unstructured content, we mean it could be text, image, video, audio, and so on. So we have an unstructured content. The model, the generative model, learns from this unstructured content. It learns patterns, and then it generates new content. So this is the difference between discriminative and generative. Discriminative try to predict, classify, but generative AI or generative models try to generate new content. So this is just a summary. We have the data. It could be labeled, not labeled, structured, not structured. We have a machine learning system and we have an output. So if the output is number, discrete, class, or probability, the model is not generative. But if the output is natural language, image, audio, video, or so on, so then the model is generative. So this is, we can model this as a function. So the output is usually y is the output. And we have the input, which is x, and the model is the function. It's tried to learn the relation between the output and the input. So we have seen supervised and supervised, semi-supervised. We have seen also the discriminative models and the generative models. There is another machine learning technique which is very exciting and interesting. It is reinforcement learning. So reinforcement learning is not discriminative and it's not generative. So it can be used for both tasks depending on the architecture and the model. So reinforcement learning in reinforcement learning, the model or the agent, we have an agent, we have an environment. So and the agent learns to behave in an environment by performing some action and analyzing the reaction. So the algorithm receives feedback in the form of reward, or it could be also penalties, and uses this feedback to adjust its behavior. So it learns, it's like a human. It learns from mistakes and experience to decide what action to take to perform a given task. So reinforcement learning has been widely used for game playing like chess, Go, Atari, tic-tac, Twiz games. It also has been widely used for robotic, autonomous vehicles, and so on. So this is the AI terminology. So we have artificial intelligence. Inside artificial intelligence, we have machine learning. Inside machine learning, we have the conventional machine learning like SVM, traditional, and also we have deep learning. And inside deep learning, we will see what there is inside deep learning. We have some models, but let's see what's. So now let's define what is AI, what is generative AI. So now we finally get where generative AI fits into the AI discipline. So generative AI, it can be considered as a subset of deep learning because it's mainly based on deep neural networks, and it can generative AI can use labeled and unlabeled data sets to train their models. So generative AI is a subset of deep learning. So according to Mike Nessin, the generative AI can be defined or refers to a branch of AI that focuses on creating or generating new content, such as image, text, video, synthetic data, or other forms of media using machine learning and deep learning models. So it does this by learning patterns from existing data, then using this knowledge to generate new and unique outputs. So the process of learning from existing content is called training. We train the model to learn from the data, and the result is the creation of a statistical model. This model, we can give to the model a prompt, and the generative AI use this model to predict or to give an answer to our prompt. So recent breakthrough in the field, like for example, GPT for or Midjourney for computer vision and so on. So there are many different types of generative AI. We have generative AI tools for text generation, which are mainly based on machine learning to generate new text. the models that had been used for text generation, it was Markov chains, recurrent neural networks, and recently the transformer. Some applications, ChatGPT, for example, we have image generation. We have tools that generate image, and they are based on variational autoencoders and generative adversarial networks, or more recently, the stable diffusion models. So some application, we could find the Mid-Journey, the Mid-Journey model, or DALI from OpenAI. We have also generative AI tools for video generation, like Deep Brain or Synthesia, and also we can use generative AI for data augmentation. Like, for example, if we want to train a supervised machine learning and we don't have enough data, we can use some techniques to generate synthetic data and to use this data to train our model. So those are some types of generative AI tools or models. So now let's discuss the key reasons behind the rise of generative AI and why it is making significant strides now. So the first reason is the availability of large and diverse data sets, which has been a game changer. So these data sets allow AI models to learn patterns, correlation, and various characteristics effectively. And also with the pre-trained state-of-the-art models, we can leverage this vast amount of data to create more accurate and sophisticated AI systems. So large data sets, the availability of large data sets is one of the key reasons behind the success of generative AI. We have also computational power. So recent advancements in hardware, particularly GPU and TPU, have drastically increased the computing capabilities. So also we have access to cloud computing and open source software, like for example Hugging Face, where you can find the existing large language models that you can use them and fine-tune them on your data sets and so on. And also we have innovative deep learning models, cutting-edge technologies like generative adversarial neural networks and the transformers architecture, and also the recent technique of reinforcement learning from human feedback. So all this helps contribute to the success of generative AI. This was just a brief introduction or a definition of what is generative AI. As I already mentioned, there are many types of generative models, but since my expertise lies in natural language processing, I will focus on large language models. But before discussing the architecture, the training process, we need to give a brief presentation of what is natural language processing. So natural language, also we will use the Venn diagram to see where natural language processing fits. So we have artificial intelligence, we have machine learning, we have deep learning. Inside deep learning, we have generative AI, and natural language processing can be seen as the intersection of all these fields. So NLP is the field at the intersection of computer science in general, artificial intelligence, including machine learning, deep learning, and generative AI, but also natural language processing is a subfield of linguistics. So the goal of natural language processing is to enable computers to process or understand natural language in order to perform tasks like, for example, translation, question answering, Siri, Google Assistants. All these applications are part or are application of natural language processing. So fully understanding and representing the meaning of language is a difficult goal. So it can be considered as AI complete or AI hard. So yeah, NLP is hard because usually the language consists of many levels of linguistic knowledge, including phonetic, phonology, morphology, syntax, semantic, and pragmatic. And as humans, we integrate all of this to produce and understand language. But for a natural language processing application or a model, it's not easy to treat or to process all these levels of linguistic knowledge. In addition to this, there is the problem of ambiguity or ambiguity, the scale, the variation, the expressivity, and the unknown representation. For example, ambiguity is the biggest challenge and it happens at several levels. Taken, for example, the lexical ambiguity, for example, we have this sentence, the fisher go to the bank. We don't know if the bank he went to the finance bank or a river. So lexical ambiguity occurs when a word is polysemous. It has more than one meaning. Also, we have the syntactic ambiguity, like for example, I can see a man with a telescope. So we don't know if a telescope refers to the man or refers to the verb can see. So it can be interpreted in different ways. We have also the semantic ambiguity. For example, I give a present to the children. I don't know if this person give one present to all the children or for every child he give a present. And also the chicken is ready to eat. We don't know if the chicken will eat or we will eat the chicken. So, and also we have the referential ambiguity, like for example, Alice invited Maya for dinner, but she cooked her own food. We don't know if she refers to Alice or Maya. So this makes NLP very hard. Also, we have the scale and the variation. We have around 7,000 language, and we have a variation of domains, news, biomedical, historical, and so on. And we need a model that we cannot build a model for all the languages or for all the application or for all the domains. So also we have the ambiguity, but also we have the expressivity, which means we can express one sentence using one meaning using different sentences. Like for example, she gave the book to Arya, we can say she gave Arya the book, and so on. And also we have unknown representation, as text is unstructured and it's difficult to construct structured representation for this input data, which is text. So large language models try to solve some of these challenges by learning from huge amounts of data. So for the moment, they could solve or they could process some levels of linguistic knowledge, but I think still needs more improvement. And so also we will draw the Venn diagram to see how large where large language models fit. So we have deep learning. We say that inside the deep learning we have the generative AI, and inside the generative AI we have LLMs or large language models. But inside generative AI we don't have only LLMs, we have other models for image, for audio, for videos, and so on. We call them the foundation models. So large language models is a subset of generative AI, and it's large because it's trained on huge amounts of data. It's general purpose because it has been trained for specific tasks, general purpose tasks. Then these models can be trained or fine-tuned for some specific purpose, but it's built for general purpose. So the architecture, so there are many types of language models. There are some language models that are based on the recurrent neural networks, or they can be based on anagrams models and so on. But the language models that have demonstrated significant success in natural language processing are those based on the transformer architecture. So the transformer architecture was introduced by Vaswani in 2017 and has since become the backbone of several state-of-the-art NLP tasks. So it is a deep neural network that consists of billions of parameters, and it has been trained on huge amounts of data sets. So we will not discuss the architecture of the transformer, but because it needs time. But if you are interested, you can check the paper, the original paper, which is Attention is All You Need. And also you will find many of tutorial on YouTube. So mainly, the LLMs can be classified according to three architecture. There are LLMs that use only the encoder, this encoder, this part. This is the encoder and this is the decoder. So there are LLMs that use only the encoder. There are LLMs like, for example, GPT that use only the decoder, and there are LLMs that use both the encoder and the decoder. So there are three different architectures. So this is timeline of language model evolution. So you can check the paper. So here you can find the models that use only the encoder. Here you can find the models that use both the encoder and the decoder. And here you can find the models that use only the decoder. And you can check for more details about the architectures in this paper. So this is the characteristics. So for example, for the models that use only the encoder or the encoder-decoder architecture, they have been trained using masked language models. What do we mean by that? We have the input data. The model masks some words, and it tries to predict the masked words. So this is the pre-trained task. It predicts masked words. So this type of model, they are discriminative. And we have the models that use only the decoder, which is the GPT style. So the training is autoregressive language models. What do we mean by autoregressive language models? Is that the model try to predict the next word based on the previous words. So the type of these models are generative because they generate new words. But for the previous or the first type, they are discriminative because they predict a class or they predict a word. So these are, and also you can check the paper for more details. So this is a simplified version of LLM training process. For example, we have the transformer, which is composed of encoding and decoding, encoder and decoder. So, and we want to translate this sentence. So, je suis étudiant. This sentence is the input. It will pass to the encoder. The encoder encodes the input sequence and passes to the decoder, and the decoder try to generate the translation of this sentence, which is I am a student. So there is massive advantage over recurrent neural networks. The transformer take advantage of parallelization and process much more data in the same amount of time, and it process all tokens at once. So this is the inner architecture of the encoder and the decoder. And for more details about this, or you can check this this tutor on YouTube, and the well explain the inner architecture of the encoder and the decoder. So for the GPT, as I said, it uses only the decoder and it doesn't use the encoder. It's based only on this part. So for the training, so now we have discussed the architecture. We said that there is the models that are based on the encoder, those based on the encoder and decoder, and those that use only the decoder. So the training. So usually the model or the language models is trained using 3 different steps. The first one is pre-training, so using self-supervised learning. Like for example, if we want to predict the masked words, the model masks some words in the input data, then it's try to predict the masked words. That's why we call it self-supervised learning. And during pre-training, the dataset is not labeled and it can be trained on Wikipedia, books, and so on. Then we have supervised fine-tuning, or it's also known as instruction tuning. So in this step, the model is trained or is fine-tuned to follow some instruction using labeled datasets. And then we have the third step, which is reinforcement learning from human feedback. In this step, the model is try to learn from humans' feedback to be aligned with human values, to reduce bias, to reduce discrimination, and so on. So those are the 3 main steps of training a large language model. Okay, so let's explain this by simple example from our daily life. For example, you have a dog and you want to train this dog. So you can train your dog using basic commands like sit, calm, down, and stay. And I think these commands are sufficient to become a good canine citizen. But if you need special service dogs, such as, for example, police dog or guide dog or hunting dog, so you need special training. So it's the same idea. First, you train your model for general purpose task. Then you fine tune or you do instruction tuning to help the model learn some specific special training or some specific task, like for example here in this case is police dog, guide dog, or hunting dog. So it's the same idea applied to large language models. And also if you want to do alignment, you can train your dog to align with human values, which is the third step. So here is the pre-training. I just want to re-explain the pre-training. So here we have the input data, which it can be collected from the web. So the model at the start, it has zero knowledge about the word. It cannot form English words, doesn't have any language skills, but with training the model using a learning objective function, it could be the next token prediction, or it could be the masked language prediction, or it could be predicting the next sentence. It depends on which learning objective we want. Then we use a giant corpus of data, and this data is always collected from internet, which is unlabeled. So here the model used the self-supervised learning. It can, as I already mentioned, it can mask some words, then predict this word. It can mask the next sentence, then try to predict the next sentence. Then after training, it learns language and it learns some knowledge. So after pre-training or self-supervised learning, we get the base LLM. It's the basic LLM, or usually we call it the foundation LLM. So for example, here, the base LLM, if we train this LLM to predict the next word, for example, if we have a prompt, once upon a time, there was a unicorn. So the model will try to finish or to complete this sentence that lived in a magical forest with all, so on. And also in this case, for example, if you give a prompt, what is the capital of France? It will not, the base LLM will not answer, but it will predict some similar sentence or try to complete this sentence. What is France's largest city? What is France's population? And so on. But the instruction tuned model, which has been fine-tuned and to follow some instruction, if you ask or if you give a prompt, what is the capital of France? the model will answer the capital of France is Paris. So this is the difference. After pre-training, we get the base LLM. Then we need to do supervised fine-tuning for some specific task. So we get the instruction-tuned LLM, and then this instruction-tuned LLM try to answer our question or to answer our prompt. So there are two ways to use LLMs. You can fine-tune the LLM. It's supervised learning. We have your own data set, and you will fine-tune, you will do supervised learning on your data set, or you can use prompt engineering. You don't need labeled data set, you don't need any data set, but just you need to specify the prompt. So why fine-tuning? So we have the general purpose, which could be GPT-3, GPT-4, or any large language model. Then we have the specialized one, which is fine-tuned, which is using instruction tuning or any other fine-tuning approach. Like, for example, we get ChatGPT, GitHub Copilot, and so on. So this is a small analogy. For example, you have your primary care physician. It's like your general purpose model, and the cardiologist or the dermatologist is the fine-tuned model, which has other specific knowledge. So, for example, here you have an input prompt, which is skin irritation, redness, itching. You give it to a base model. The output could be probably acne. But if the model is further fine-tuned on dermatology data, you will have another output. You have a mix of non-inflammatory, and it will give you more details. So fine-tuning steers the model to more consistent output, reduces hallucination, and customizes the model to a specific use case. So we have discussed the fine-tuning. Now let's present briefly the prompt engineering. So now prompting is also revolutionizing AI application development. So for supervised learning or fine-tuning, we need to get the labeled data. We need to train AI model, and then we need to deploy the model. It took around 3 or 4 months. But for prompt-based LLM, you need just to specify the prompt and then deploy the model. It can take some hours or some few days. So prompt engineering is the practice of designing and refining specific text to guide generative AI such LLM in generating desired outputs. There are some types of prompting technique, including the in-context learning, chain of thought, self-consistency, knowledge generation prompting, React, and so on. So now researchers are focusing on developing more sophisticated prompting techniques. So here, text-to-text foundation models, since GPT, those is just a summary of the existing LLMs models. These models can be open access, closed access, or limited access. Here you can find the models that is open, closed, and limited access. And I think I still have 4 minutes to recap. So here I can, I will be fast done. So here we will summarize how LLMs are built. So the first thing to do is to collect data, to clean this data. Then we need to tokenize this data, to split data into tokens. There are some methods like byte pair, word piece, sentence, and so on. Then we need to do the positional encoding in order to see the position of words in a sentence. Then we need to choose the architecture. It could be encoder only, encoder, decoder, and so on. Then we need to choose the pre-training objective function. It could be masked language modeling, causal language modeling, or next sentence prediction. And more recently, there is the mixture of experts. Then after pre-training, we have fine-tuning or unstructured tuning. Then after fine-tuning and unstructured tuning, we have the alignment with human values using reinforcement learning, for example, from human feedback, but there are other methods, of course. We need also to choose the decoding strategy to generate the final text, and we need to test our model, which is, or sometimes we need to use some other fine-tuning efficient methods to reduce the number of parameters and so on. So this is the general architecture. So you can use them, LLMs, to build web-based interface like ChatGPT bot, or you can use them to software-based application like email routine, document search, and so on. So the benefits of using LLMs, a single model can be used for different tasks. The fine-tuning process requires minimal field data, and the performance is continuously growing with more data and parameters. Here you can see the LLM's capabilities. You can check these recent papers about the capabilities of LLMs. Some limitations, sometimes they lack common sense, their inability to handle complex tasks, limited knowledge base, and lack of emotional intelligence. And sometimes they provide biased data or biased outputs. Sometimes they suffer from hallucination. And to conclude, I think in order to classify a cat, we need to describe this cat using traditional programming, the type, the legs, the ears, but with the wave of neural networks, these neural networks just learn from the data and then they classify these cats. But today with the generative AI, you don't need label data sets, you don't need anything, you just need the prompt and the model will classify, will give the class of the input image, for example. So I will finish by a question that everyone needs to ask. Is generative AI a threat of an opportunity for my business? How exactly can I use generative AI to gain a competitive advantage? And how can I use my data securely with generative AI? So I think this question will be answered by my colleagues in a next slide or next webinar. I think it's a responsible AI. I think, is it?
Thank you, Salima, for the nice presentation, and thank you for the extra work you give it to me for the next webinar.
No, but no, I thought it's the next webinar is about responsible AI, not?
It's about AI and human social contract, how both can work together. So what are the term and responsibility that AI can have in a social contract with the human, because the AI has not to deal with the decision making, but has to be checked every time by human, and this is the purpose of the next talk.
Okay.
But, okay, I will be answering them next time. Thank you so much.
Welcome.
Yeah, we have here some question from the chat. Hope to have more in the chat. Yes, you can read the question, Salima?
Yeah, I can, but yeah. But
okay.
There is one question: is convolutional neural network not feed-forward neural networks? Yeah, this one. And are we in chapter 4? I am sorry. What do we mean by feed?
No. You can see the shared document by Thomas, because don't see the question in the chat. We just collect them and put it in this document. Do you see the screen of Thomas? Because we are sharing the question with all.
Yeah, I can see, but I cannot change the. I just see 3 questions.
Yes, there are 3 questions. Yes.
Okay, so the first question is convolutional neural network, not, no, convolutional neural networks is a subfield of feed-forward neural networks, because usually when you have doing supervised, you have feed-forward and back propagation, so it could be considered as subfield of, as subset of feed-forward neural networks.
Can you read or do you need help?
No, I can. How does ChatGPT or GPT translate sentences since it uses only the decoder? So even for the decoder, if you see it's the same architecture as the encoder and you have the input sentence, you encode it using the self-attention, then it's trained to, using labeled datasets, it's trained to translate the sentence. So it's not.
Okay, I can answer this question if you want.
Yeah, of course, for
because
sure.
it's a really good question, and thanks to Jean Didier for this question. So ChatGPT use a model architecture based on the transformer, like explained by our speaker Salima, which typically include both encoder and decoder in its full configuration. However, ChatGPT itself specifically designed for generating text, primarily function through the decoder component of the transformer architecture. So in a full transformer model, like those used in a translation task, the encoder process the input data and the decoder generates output based in that. This is what happened when we use the full architecture of transformer. But keep in mind that ChatGPT is designed to optimize, or it is optimized for generating text. So it has this capability itself. So it doesn't need too much the encoder to process the data, but it needs the decoder for the translation. That's why. So that's why the translation go through the decoder compared to the encoder, because ChatGPT itself, it is optimized for generating the text. And this is my answer to this question. Yeah, thank you. Salima, go ahead with the last one.
Are there statistics which types of LLM perform better across different language? So I will answer this question. It's not about statistics, but it's more about evaluation, the models on other different language. So for now, I think GPT is the most powerful model for handling many languages, and especially those with which are considered low resource language like Arabic and other languages, Luxembourgish and other. But it depends. For example, it can some large language models can perform well on machine translation in this language, for example, but it cannot perform well on text summarization for other language. So it depends on the task and it depends on the language, and usually we need to do evaluation to see which language perform better than the other, which model perform better than the other models.
Thank you. As this was my question, I'm using my unfair advantage of being able to speak, so thank you. It's different than from what generative grammar means in linguistics, basically. So we talk about different structures or different architectures here.
Yeah, indeed, because there are many observations and studies indicating the performance of large language model, let's say BERT, ChatGPT, Gemini, or other large language model that exist. All of them vary significantly across different languages. And this is something that we touch in our research, like, for example, supervising student to develop an application for Luxembourgish language accusation. So we are facing with the issue of the lack of data in Luxembourgish languages. So ChatGPT, it performed good to have some knowledge in that, but we need to be deeper in explaining the course, or in particular to speak in Luxembourgish. And this issue is in the difficulty it is displayed as an issue for grammar, for linguistic field, because it depends to the data we provide to the model. If we don't, if the model that it doesn't represent, if the data we provide to the model doesn't represent the other style, dialect, or other languages enough, it cannot output the desired. It doesn't generate the desired output, and this has come from the lack of the data that the model that doesn't have the opportunity to see during the training process. Even if we give example, it's not enough compared to the model who has been trained in enough data to understand all the linguistic field of this knowledge. Yeah. Does we have any question in the chat? You are receiving a good comment in the chat, Salima.
Yeah, I'm receiving, but yeah, thank you. I am reading.
Thank you for all of you. Yeah.
Thank you so much.
So yeah, we still have some time if you have some question. Here someone put yeah, from Norbert Nobin. ChatGPT use a decoder-only architecture to generate a response. This architecture relies on the decoder component of the transformer model, which is responsible for generating text based on the input it receives. The decoder process the input text and generate the output text in the token.
Okay, thank you so much. Thank you all for your time and
predicting the next token. I'm reading predicting the next token in the sequence based in the context it has learned from the input. This process alone. Yeah, thank you for the explanation. Yes, that's great. Yeah, this process allows ChatGPT to generate coherent. Yeah, that's true. Okay, is there any question in the chat? Okay, then I think yeah,
we have done.
Yeah.
I will stop the recording. Thank you for the presentation.
Yeah. Thank you.
It was very engaging. It was interesting for me personally as well.
Yeah.